fuselage is the main body of an aircraft and forms the central structural component to which the wings, empennage, tail, landing gear, and engines are attached. It houses the cockpit, passengers, cargo, and aircraft systems, such as avionics, environmental control systems, and electrical equipment. Structurally, the fuselage must carry and transfer aerodynamic, inertial, ground, and pressurization loads while maintaining its shape and ensuring occupant safety throughout the aircraft's operational life. Primary components are the main load-carrying members of the aircraft structure. These components are responsible for carrying aerodynamic, inertial, ground, and pressurization loads, and their failure can lead to catastrophic loss of the aircraft. They are designed with strict strength, fatigue, and damage tolerance requirements, and are subject to rigorous inspection and certification standards. Secondary components are structural members that support the primary structure and carry localized or redistributed loads, but they are not critical to overall structural safety. Failure of a secondary component does not immediately cause loss of the aircraft, although it may affect operation, comfort, or functionality. These components are designed with lower load requirements compared to primary structures. Primary components of fuselage. The fuselage skin is the outer covering of the aircraft and is a primary load-carrying element in semi-monocoque construction. It mainly carries shear loads and pressurization loads and also contributes to resisting bending and torsional loads. In pressurized aircraft, the skin experiences hoop and longitudinal stresses due to internal cabin pressure. Additionally, it provides a smooth aerodynamic surface and protects internal structures from environmental effects. Frames are transverse structural members arranged circumferentially around the fuselage. Their primary function is to maintain the fuselage cross-sectional shape and prevent skin buckling under compressive and pressurization loads. Frames also help distribute concentrated loads from wings, landing gear, floors, and doors into the surrounding structure. Bulkheads are heavy frames designed to carry significant loads and separate different sections of the fuselage. They transfer major loads such as wing attachment loads, landing gear loads, and pressurization loads. Pressure bulkheads are used at the ends of pressurized cabins to seal the cabin and withstand high pressure differentials. Stringers are longitudinal stiffeners attached to the fuselage skin and run along the length of the aircraft. They primarily resist axial tensile and compressive loads caused by fuselage bending. Stringers also support the skin and increase its resistance to buckling, thereby improving structural efficiency. Longerons are major longitudinal structural members that run along the fuselage length. They carry significant bending loads and provide overall longitudinal strength to the fuselage. Longerons work together with frames and stringers to form a rigid and stable fuselage structure. Secondary components of fuselage. Floor beams are structural members that support the cabin floor and carry loads from passengers, cargo, and seating systems. These loads are transferred through the floor beams into the fuselage frames and skin. Floor beams also contribute to the overall stiffness of the fuselage. Doors and windows create cutouts in the fuselage skin, which weaken the structure locally. Reinforcements are provided around these openings to restore strength, prevent crack initiation, and safely transfer loads around the cutouts. These reinforcements are critical in pressurized aircraft due to high stress concentrations. Fairings and access panels are used to cover joints, systems, and structural connections while allowing maintenance access. Although they carry little or no primary load, they improve aerodynamic efficiency and protect internal components. Access panels are designed for easy removal without compromising structural integrity. The pressure dome, also known as the pressure bulkhead dome, is used in pressurized aircraft to seal the cabin ends. It resists high internal cabin pressure and prevents air leakage. The dome shape helps distribute pressure loads efficiently, reducing stress concentration and improving fatigue life.